This video is going to introduce the concept of conditional probability. And the big question with conditional probability is what I have written here on the top of the slide. Basically, we're looking at how the fact that one thing already happened affects the probability of something else happening. So we're kind of saying something's already done. How does that change what we're looking at now? The typical notation you'll use for conditional probability is written right here. You'll see probability of something, you'll see like a vertical bar and something else. You pronounce this the probability of A given B. So this vertical bar right here essentially stands for the word given. What that means if B is given is that it already happened. So if we're looking at a probability, the second part over here, the part that's given, is already done with and over, and you have to adjust your probability accordingly. We're going to look at a couple examples of how that plays out. And conditional probability can get fairly difficult, but we're really just going with an intro in this in Algebra 2 here, and maybe in a stats class or something you'll see it in more detail. With these kind of probability questions, you can really just kind of think about them and use common sense to get your answer. So we're going to pick a few cards out of a deck without replacement. Again, that means you don't put the cards back, which means that the events are dependent. And what we're saying here is the probability of the second card is going to be a heart, given that the first one was a club. So we already got a club on the first card. That is done. It's over with. We're moving on. So one of those clubs is sitting right over here on the table. Well, if the first one was a club, I know there are only 51 cards left in the deck right there. I want to find the probability that my next one is a heart. There are still 13 hearts because we're saying I took out a club on the first one. So it's just going to be 13 over 51. You can turn that into decimal, but that problem is done. On our second one here, we're looking for the probability our second card is a king, given that the first one was a king. So we already picked our first card. It's done with, it's over with, it's a king, and it's sitting there on the table. So there are only 51 cards left. We want to find the probability the next one's a king. Well, we're saying we already picked a king. That means there's only 3 kings out of 51 left in the deck right there. So 3 out of 51 can be reduced if you want to, or you can go with a decimal. That's the same thing as 1 over 17. And finally, for the last one here, we're looking for the probability the fourth card is red, given that the first 3 were all spades. So we're saying, you know what, this is already done with. We already got 3 spades. If we picked 3 cards, that means we're down to 49 more cards in the deck out of our 52. And spades are black cards, so if the first 3 were all black cards, there are still going to be 26 red cards left in the deck. So we have 26 out of 49, which does not reduce. You could turn it into a decimal if you like. It's 0.531, roughly.